Several U.S. and international military helicopter avionics upgrade and research and development programs are demonstrating the way smarter displays, smaller computers, and more intuitive navigation systems will become standard in the next generation of vertical lift platforms. Here, Avionics International highlights new avionics technologies being developed for existing and future military helicopters by some of the largest airframe manufacturers and systems suppliers in the world. The Future Vertical Lift (FVL) initiative has two main programs: Future Attack Recon Aircraft (FARA) and Future Long Range Assault Aircraft (FLRAA). The Army describes FARA as a knife fighter helicopter that will fill the gap left by the retired the OH-58D Kiowa Warrior. In contrast, the competitive demonstration effort for FLRAA is intended to deliver an initial concept design for the helicopter that will ultimately supplement the Army's U-60 Blackhawk helicopter fleet for fast assault medical evacuation roles and, in the long term, to replace the Blackhawk. Overall, the FVL program will produce replacements for the Apache, Blackhawk, and Kiowa Warrior. Mike Hirschberg is the Vertical Flight Society's VFS executive director and a consultant to the FVL program that he calls one of the most exciting things to ever happen in the military helicopter world. The new air vehicle architecture is seen as enabling leap-ahead technology advances, and while the faster speeds are helpful, to Hirschberg the most notable advancements are the dramatic improvements in range, maintainability, supportability, fly-by-wire, FBW, flight controls, and advanced avionics architecture. Bell's Invictus 360 FVL FARA contender provides an example of where military helicopter cockpits are going in the future. The Invictus, with its low-drag tandem cockpit design, draws from a lot of the development Bell has put into the 525 Relentless, a super-medium utility aircraft it hopes will be the first fly-by-wire rotorcraft certified for the civil market. Lee Anderson, Bell's FARA program manager, covered some prime virtues in an interview with Avionics. Invictus features large area displays and adaptive touchscreens to maximize flexibility while adapting to different operational scenarios and employing many capabilities. Some are destined to be required when dangers suddenly arise in combat theaters and information sharing with friendlies is crucial. Then, strong tactical data links and system interfaces will let the helicopter connect seamlessly with both tactical forces and command and control nodes. Some observers of the FVL program are concerned that given the FARA and FLRAA winners' fielding is a decade hence, and foes' capabilities are largely unknown, developers must try to prepare to meet and ideally outpace them. Anderson believes that the use of open architecture design with rapid upgrade capabilities is the key to overcoming that reality. The key challenge for avionics is the cost and time required to develop, qualify, train and field new capabilities. Our modular open approach, MOSA, enables rapid integration of new capabilities from different vendors. According to Anderson, the configurable flight displays on Invictus let crews maximize the limited space available in the cockpit as new capabilities are added to the aircraft. The trend in downscaling computers and other flight deck resources is also expected to help. More processing power in the same space and weight enables more data fusion, better situational awareness, and more autonomous capabilities, Anderson says. Flying Invictus will grow more manageable, Anderson believes, so that operators can focus on employing its disparate weapon systems. Other unknowns are challenges implicit in the extended reach of instruments, comms, radar, fire control, and other tools under combat conditions. Increased speed and range requires improvements in sensor and communications performance, Anderson says. Increased standoff distances, too, improve survivability as threat systems also become more capable. Those systems include the Electronic Attack and Countermeasures (ECM) arena, where several reports published in 2021 suggest China and Russia are making daunting progress. Anderson said, the Bell 360 will be equipped with a suite of defensive systems designed to improve combat survivability. As with other aircraft systems, MOSA allows those systems to evolve rapidly to keep pace with potential dangers. The French Armament General Directorate, DGA, signed a contract with Airbus Helicopters announced on December 22 for the development and procurement of the H-160M in the frame of the Light Joint Helicopter Program, HIL, deemed the Guépard by the French Armed Forces. The contract includes the development of several prototypes and the delivery of a first batch of 30 aircraft, 21 for the Army, 8 for the Navy, and 1 for the Air Force. The French Ministry for the Armed Forces plans to order a total of 169 H-160M helicopters. With deliveries of the first batch of Guépard rotorcraft scheduled to begin in 2027, the communication, navigation, and surveillance systems being developed for it represent a glimpse into the military helicopter avionics of the next generation. That's where the Thales Flight X cloud-native cockpit system comes in. The modular touchscreen-centric system was first unveiled by the Toulouse-based avionics maker in 2019, built on the concept of virtualizing communications, navigation, and surveillance systems by giving them native or embedded data sharing access to cloud and ground-based aviation systems. Computing and processing for Flight X is embedded directly into the 1-to-4 display configuration of the system, eliminating the need for separate avionics computers, as the display is now the computer. Indeed, Flight X is a cloud-native avionics suite. Today, thanks to Flight X, the pilot is able to display and interact with his connected EFB, electronic flight bag, directly on the avionics screen, a representative for Thales said in an emailed statement to Avionics. In a second step, Flight X will be directly connected in a cyber-secured way to external systems in order to use data from the open world in the cockpit itself. Thales began flight testing a single-screen version of Flight X in a modified Cabri helicopter in September, a flight test campaign that will continue over the next 1 to 2 years. Other features of the H-160M Guépard include the Safran Euroflir 410 electro-optical system and Airmaster C radar. H160M pilots will also be able to integrate the helmet-mounted display into the H160M's fly-by-wire system. The Guépar helicopter will carry a self-protection suite, a satellite communication system, and tactical data link system. Commenting on the signing of the contract to acquire a fleet of H160M helicopters in December by the French DGA, Bruno Even, CEO of Airbus Helicopters, called the new light helicopter the result of 10 years of close cooperation with the DGA and the French armed forces. The H160M will bring new capabilities to the armed forces as it is adapted to modern warfare thanks to its increased connectivity, maneuverability, low acoustic footprint, and a fully integrated support system. Having the French armed forces, a world reference, as our launch customer for the H160M is extremely valuable, Even said. Amid the effort to develop a variety of future vertical lift replacements for it, the U.S. Army is still investing millions into refreshing its current fleet of Blackhawk helicopters. At the timing of Avionics going to print with this article, the Defense Advanced Research Projects Agency, DARPA, is planning its first fully autonomous A-60 Blackhawk flight with no safety pilots on board in January, with the Army assessing how it may leverage the technology for its enduring helicopter fleet. A lead program official for DARPA's Alias program, which has been running for about 6 years, told reporters during the Project Convergence event held in Yuma, Arizona, in November that he anticipates the technology transitioning to the Army in the near future as the service anticipates potential use cases from aircrew augmentation to potential completely autonomous operations. During the Project Convergence event, the Army remotely conducted the first autonomous launch of an air-launched effects small prototype from a Blackhawk using the Alias technology. It makes common fiscal sense that we're going to have these very expensive future vertical lift, FVL, assets and there's going to be missions where you'll say I don't need to send in a very expensive aircraft when I can send in an automated legacy or enduring aircraft. How the Army decides to use those is something the Army needs to figure out, but at least we have the technology to be able to do it, Stuart Young, DARPA's program manager for Alias, told reporters during a media briefing held after the Project Convergence experiment. Drilling further down on the Blackhawk 60 volts, Victor, unveiled last year at a National Guard base at a modernizer showcase, it's getting an entirely new cockpit from Northrop Grumman via their open-lift avionics suite. With a user interface almost identical to earlier iterations, Blackhawk pilots can easily transition from the M to the V generation. An overarching challenge for military helo operations is balancing component size and weight with sheer elbow room. Dennis Neal, Northrop Grumman's Director of Integrated Digital Systems, concurred in an interview, telling Avionics, our experience with other aircraft and programs, infrared countermeasure, models, and the H-1 helicopter, as two examples, have given us insight into techniques for reducing open-lift space and weight. Apart from a common look with the M, the V is to have significantly advanced avionics, such as new mission computers, including a Flight Pro Gen 3 mission computer. The UH-60V also has the same type of localizer performance with vertical guidance, LPV, used by commercial aircraft to help landings in low visibility conditions and remote locations. The UH-60V also marks Army Aviation's first qualification of multi-core processing for flight critical functions. In all, OpenLift gives the Blackhawk a digital transformation. Neal explained that 4 glass screens, for example, supplant the 60V's analog gauges. Additionally, Neal says, the OpenLift architecture will allow Blackhawk operators to select avionics hardware and software from any vendor for future upgrades. OpenLift also features the integration of a forward-looking infrared, FLIR, system where a separate control stick and display were previously used. The first UH-60V Blackhawk helicopter to feature the OpenLift avionics suite entered service with the Pennsylvania National Guard's unit at Fort Indiantown Gap in August. We are excited, concluded Neal, to continue to support the Army as it modernizes hundreds of A-60Ls in the future. Avionics software aligned to the open system architecture of the Future Airborne Capability Environment, FACE, technical standard is increasingly being developed and becoming available for insertion and operation within fixed, rotary wing and unmanned aircraft operated by airborne segments of several U.S. military services. FACE Consortium first released edition 1.0 of the FACE technical standard in 2012 with the goal of providing a common computing infrastructure that would allow software to become more portable and be reused across different military aircraft. During recent discussions with Avionics International, several of the avionics systems integrators and suppliers involved in the FACE Consortium, Open Group and the Aviation Division of the U.S. Army's Program Executive Office, PEO, provided a status update on FACE software use within current military aircraft and some of the next steps needed to make adoption of this open systems approach a widespread reality for the military aviation community in the future. The Open Group FACE Consortium has over 90 member organizations, with 7 new members joining in 2021. This represents consistent and increased interest and adoption of the FACE technical standard ad business approach by U.S. government, industry, and academic organizations, Judy Sorenzia, Vice President of Forum Operations at the Open Group, told Avionics in emailed statements. The latest updated information featured in the procurement section of the Open Group's FACE Consortium includes 4 requests for proposals, RFP, issued by the U.S. Navy with FACE reference architecture requirements including a containerized flight training device configuration upgrade and a $1.02 billion Next Generation Jammer Technology Award as well. Additionally, the Army, Navy and U.S. Special Operations Command, USSOCOM, have issued 37 different requests for information, RFI, that include FACE conformance requirements since 2013. There are also now more than 25 software products from 13 different suppliers featured in the FACE software registry. A representative for Army PEO Aviation told Avionics that the service is currently designing an Aviation Mission Computing Environment, AMCE, using the FACE technical standard and architecture as the software baseline for mission systems processors for both the current rotary wing fleet, Apache, Blackhawk, Chinook, and the future vertical lift, FVL, family of systems. PEO Aviation envisions using the AMCE to enable the instantiation of avionics software applications that conform to the FACE architecture across these multiple aircraft types that provide alert messaging, chat management, common operating picture presentation and aircraft data loading, among other capabilities. The office has established an Architecture Collaboration Working Group, ACWG, that is now responsible for establishing a common set of requirements for a foundational architecture to be used in avionics systems development and upgrades for in-service and next-generation aircraft. These architecture requirements will be used in conjunction with other systems engineering requirements to form the requirements baseline, GFI, for FVL development and enduring fleet modernization. This architecture is to comply with the modular open systems approach in accordance with the National Defense Authorization Act for fiscal year 2017 and 2021, the representative said. Probably the biggest program goal or milestone related to FACE, in 2022, would be the release of the Future Long-Range Reconnaissance Aircraft, FLRAA, request for proposal anticipated for FY22. The Open Group has released new editions of the FACE standard periodically, including the latest 3.1 edition, which is a 586-page document that provides an overview of the FACE reference architecture and an explanation of each segment and interface. According to the document, the FACE reference architecture, the guidance that allows developers to create avionics software applications and layers aligned to the standard, is divided into 5 different segments, including the following: Operating System Segment, OS, Input, Output Services Segment, IOSS. Platform-Specific Services Segment, PSSS, Transport Services Segment, TSS. Portable Components Segment, PCs. The visual representation of the FACE reference architecture above was shown by Arun Subbarao, VP of Engineering for Lynx Software Technologies during a December webinar about FACE 3.1 that he participated in. The segments are divided according to portable and platform-dependent functionality. The high-level overview of the FACE reference architecture with software and system components supplied by Lynx and iData shows how new avionics applications can be developed to conform with the FACE technical standard. By segmenting the software components in this way, the standard provides isolation of avionics hardware from changes, updates and reuse of the software across different aircraft types. Avionics companies following the reference architecture depicted in the diagram meet the requirements of the individual segments as outlined in the standard document with individual units of conformance, UOC, which the FACE consortium defines as a software component or domain-specific data model designed to meet the applicable requirements defined in the FACE technical standard. It is referenced as a UOC at any point in its development, and becomes a FACE-certified UOC upon completion of the FACE conformance process, according to the FACE 3.1 standard document. During the U.S. Army FACE Technical Interchange Meeting, TIM, held in September, demonstrations by several avionics systems integrators, software suppliers and vendors provided examples of what the FACE reference architecture looks like inside of actual aircraft systems. One demonstration at the TIM featured Collins Aerospace as the lead avionics systems integrator working in partnership with General Atomics Aeronautical Systems Inc., Perry Labs, Tectonics and Palantir Technologies, among others. Dave Schreck, Vice President and General Manager, Military Avionics and Helicopters for Collins Aerospace, described how the demonstration visualized the open system architecture of FACE in emailed statements to Avionics. Collins supplied the FACE Transport Services segment, a software layer that essentially allowed the other 18 software applications to talk to each other. Those software apps included things like tactical synthetic vision, flight control and payload control, according to Schreck. General Atomics provided UOPs that encompassed the logic to command, control and communicate with U.S. Army Gray Eagle. This software was reused from on-contract work with the PMUAS, ground modernization, where the software is currently deployed, Schreck writes. Tectonics provided UOPs that correlated to the General Atomics logic-based applications but were tailored for our large area displays, LADs, to provide the ability to control a Gray Eagle using a touchscreen in a helicopter versus the original intended use of a ground control station with a keyboard, mouse, and joystick. The Army remains one of the leading military aircraft operators advancing FACE acceptance and adoption as noted in the number of RFPs and RFIs issued and awarded by the service branch in recent years. Schreck noted that reuse opportunities like the one demonstrated at the TIM event will increase for the Army once PEO Aviation releases an enterprise product architecture that creates common definitions of capability and how those capabilities interface with each other. That capability grouping is currently being referred to as a major system component by the Army, but will likely change to product specifications sometime in 2022, according to Schreck. In addition to the technical challenges, a new business model is also needed for DoD and industry to apply open system integration like this. In the past, suppliers would typically sell the hardware and give the software away for free, but in the future it may be the other way around. DDCI, Inc., the Phoenix, Arizona-based software company, is another RTOS supplier embracing the principles of FACE that participated in the September FACE TIM as well as the 2021 Aerospace Tech Week event in Toulouse, France. Their Deos RTOS first achieved FACE 3.1 conformance for the Operating System Services segment in 2019, and continues to publicly demonstrate what the open system architecture can provide on military aircraft. At the current time, the target audience for FACE is the U.S. military, although there is growing interest in other NATO countries as well. Gary Gilliland, Technical Marketing Manager for DDCI, told Avionics during a recent interview. If you look at FACE from an OS perspective, the goal of the specification is to abstract the operating system from the applications such that applications can be run on any system regardless of the operating system, OS. The ARINC 653 specification, which is part of the FACE technical standard, already provides common architecture and APIs that have been shown to be easily portable between COTS operating systems in the DO 178 space. Since the FACE reference architecture builds on a common computing infrastructure, as more military aircraft technology procurement leaders release enterprise product architectures that include FACE, it will increasingly become easier to reuse individual avionics applications across multiple aircraft types in the future. Real-Time Innovations, RTI, the Sunnyvale, California-based software framework company, is also a big believer in embracing FACE as part of a broader MOSA approach to military avionics systems. Chip Downing, Senior Market Development Director, A&D at RTI told Avionics that the open APIs providing the interfaces between FACE software segments are key to its ability to enable replacement or reuse of FACE avionics solution stacks. I suspect that most capabilities reused between different aircraft platforms will be a simple duplication of an existing FACE solution stack with the underlying hardware platform, Downing says. The second most common will be replacing applications, also known as units of conformance, UOCs, on top of a working FACE avionics stack. The FACE software segment that will require the most work in these reuse scenarios will be the Platform-Specific Services segment, PSSS, that maps the capabilities from a specific aircraft type into the FACE avionics stack. The Open Group is also working to advance future development of avionics software aligned to the FACE technical standard. In December, the FACE Consortium announced a new training accreditation program for new courses designed to help people acquire the necessary knowledge and understanding of the FACE standard and the FACE conformance program. The Open Group FACE accreditation program represents a significant milestone in the FACE ecosystem by adding training and education to support the procurement of avionics systems, Steve Nunn, President and CEO, the Open Group, said in a press release announcing the new program. Accreditation from the Open Group provides a mark of quality, that course materials and training provisions meet the high levels of professionalism that the Open Group requires. This will undoubtedly accelerate the adoption of the FACE technical standard and conformance program, bringing benefits to buyers and vendors alike. The Agility Prime program, launched in May 2020 as a U.S. Air Force effort within the AFWERX program, has accelerated electric air taxi technologies and supported commercial investment in electric vertical takeoff and landing, eVTOL, aircraft. Agility Prime has worked with numerous companies to award more than $100 million in contracts, with 4 company recipients going so far as to achieve military airworthiness. In 2021, the Agility Prime program made significant progress, and 2022 is primed to be a year filled with more milestones en route to sector benchmarks of greater magnitude. On the horizon, for instance, is the 2023 goal for beginning eVTOL operations with an initial use case. Collaborations with the armed forces proved fruitful this past year. In March 2021, a LIFT eVTOL aircraft was transported using a military aircraft for the first time. LIFT aircraft, which was chosen for the Agility Prime program in April 2020, accomplished this task in collaboration with airmen from the 355th Wing and 621st Contingency Response Wing. HEXA, LIFT's eVTOL aircraft, was loaded onto HC-130J Combat King II and flown from Springfield, Ohio, to Austin, Texas. While the operation was successful, there is still room for growth in streamlining the flight experience. The load time, for instance, on HEXA's flight was 40 minutes. Though the flight operation was a proof of concept effort, according to Jace McGowan, flight development engineer and chief pilot with LIFT, trimming time is a priority. We are also working to get the time from unloading it off the aircraft to ready to fly down under 2 hours, he said. The HEXA eVTOL has numerous applications including personnel recovery and initial airfield assessment missions. AFWERX Prime Division Chief James Birilla spotlighted technological versatility, noting that his team's aim is to find emerging technology with dual capabilities and transition to deploy them rapidly. After working with many mission partners, to meet the needs of our operators and warfighters, he stated in a release from the official USAF website. Moving forward, the 355th Wing will test more in-depth use cases to further broaden the capabilities of an eVTOL within rescue and attack operation contexts. In the new year, LIFT will also be looking to broaden eVTOL applications outside of the tactical contexts characterizing their work this past year. To that end, by the end of 2022, LIFT plans to offer flights for members of the public, according to statements made by LIFT Director of Business Development, Kevin Rostagi, in an interview with Avionics International. The company is exploring use cases such as cargo transportation, first response, and water landing. The cargo version of the aircraft could make its appearance this year, and a vision for water landing could be coming sooner rather than later. In a future that's not too far out, Rostagi suggested, the pilot could jump out to perform a water rescue operation and have the aircraft hover in place. LIFT has also set a goal of raising $5 million from public investments through the equity crowdfunding platform Start Engine, and the company has raised over $2.5 million to date. Along the way, LIFT is making further improvements to the eVTOL's design. As the team at LIFT focuses on the HEXA's single-seat layout, they hope to extend its range while also ensuring the robustness of the flight computer. The U.S. Air Force's first airworthiness approval for a manned electric aircraft was awarded in May 2021 to Beta Technologies after over a year of examinations and evaluations by Air Force engineers. Beta, one of the partners of the Agility Prime program, had recently entered a new phase of flight testing. After the airworthiness approval, the company could begin flying its ALIA aircraft as part of the Prime program, and the Air Force gained access to Beta's 2 immersive eVTOL simulators and training facilities. Colonel Nathan Diller, director at AFWERX, looks forward to the enhanced abilities of Air Force acquisition professionals to make data-driven decisions informed by real assessments of military utility, based on the agreement with Beta. The engineering, test, and acquisition professionals in Air Force Materiel Command have phenomenal expertise to help accelerate this and other emerging markets, he noted in a press release announcing the Agility Prime program agreement with Beta. A spokesperson for Beta shared in a recent Q&A with Avionics how the USAF partnership includes work to define range, altitude capabilities, endurance, and payload limits in addition to numerous mission profile evaluations for the ALIA aircraft. In 2022 and beyond, the team will test even more specialized cargo and logistics missions as the partnership continues, in concert with the USAF, adhering to their protocols. These exercises help inform better designed aircraft and push us toward commercial viability. One example of this lies in our ground vibration tests last year. With the support of USAF, we were able to access research labs, experts, and equipment as we conducted this vital testing. In May 2021, AFWERX's Agility Prime program and partner Kitty Hawk marked a significant achievement by conducting a successful operational exercise. A month later, Kitty Hawk's heavyside eVTOL aircraft was assessed for its performance in medical evacuation and personnel recovery. The exercise also allowed Kitty Hawk's team to demonstrate the heavyside aircraft's remote flying functions. In July, shortly after the heavyside's medical evacuation exercise, AFWERX shared the news that the Air Force had awarded airworthiness approval to Kitty Hawk. This designation marked a meaningful milestone since it allowed Kitty Hawk's aircraft to enter its next phase of flight testing in coordination with the Air Force. Kitty Hawk's core technologies, distributed electric propulsion, fly-by-wire flight controls using redundant flight control computers, remote piloting that evolves into true autonomy, and low-cost manufacturing techniques, will all be instrumental in meeting the Air Force's unique requirements, stated Matt Croce, Director of Service Operations at Kitty Hawk, in an interview over email with Avionics. Croce also commented that the team is in the early stages of development on a new technology that could be transformative for future transportation. As for the upcoming year, he said, it is our intention to conduct our first remotely piloted flight with a human on board as well as expand on our beyond visual line of sight capabilities that we demonstrated late last year. The Air Force's commitment to the advancement of eVTOL aircraft was also evident in its selection of software company Tangram Flex to sign a Small Business Technology Transfer (STTR) contract in December 2020. A second STTR contract was granted to Tangram in August 2021 as an extension of the original contract, serving to advance drone and air taxi cybersecurity within the Agility Prime program. Ohio State University will partner with Tangram for the second phase of the contract, focusing on streamlining drone and eVTOL analysis, testing, and ensuring its vehicle's safety within the Agility Prime program. In September, the Air Force and Archer Aviation announced an agreement to explore possible Air Force applications of Archer's Maker eVTOL aircraft. Flight test data provided from Archer will inform AFWERX's Agility Prime program of the Maker aircraft's suitability for various purposes. In December, Archer became one of just a few companies to receive its special airworthiness certificate from the FAA. During that same month, the company also announced that its Maker aircraft completed its first successful hover flight. Archer will focus next on including hover envelope expansion and transition envelope expansion in their flight test campaign. The partnership between the Agility Prime program and Archer is dedicated to discovering potential applications for the Maker aircraft in the coming year. Another milestone for the AFWERX Agility Prime program in 2021 came from one of its partners, Moog Aircraft Group, which created a prototype eVTOL. The U.S. Air Force will test its aircraft, the Surefly S-250, for technical maturity in addition to unmanned flight capability, costs, and risks. Agility Prime Program Manager Darshan Divakaran commented on the limitations of full battery electric propulsion systems in a statement published to their website. With the Surefly, the Air Force will get a more in-depth understanding of hybrid electric power system technology and also Moog's aircraft control systems, explained Divakaran. In completing the process for military airworthiness through the Air Force, Moog's Surefly will be able to continue flight tests at an unmanned aerial system, UAS, test site on an ongoing basis. One of Agility Prime's 2022 goals is to enable routine initial skills training for operators of AAM vehicles. An October 2021 announcement noted that Air Education and Training Command set up Detachment 62 with the aim of establishing training for the Agility Prime program as well as setting eVTOL certification standards. During the keynote presentation at the AUVSI, Association for Unmanned Vehicle Systems International Unmanned Systems Defense Virtual Event in 2021, Colonel Diller said that an eVTOL aircraft could be used by the U.S. Air Force's Agility Prime program as early as 2023. Over the course of 2022, multiple different use cases will be analyzed in order to achieve operational capability for the Air Force by next year. In December, the FAA gave Joby Aviation its special airworthiness certification for Joby's second pre-production eVTOL prototype, and less than a week later, the USAF granted the company its airworthiness approval for the same aircraft. Both approvals will increase Joby's capacity for flight testing in 2022, and the eVTOL will soon be put into service within the Agility Prime program. Joby was the first eVTOL company to sign a G1, Stage 4, certification basis with the FAA, which happened in 2020. Joby Aviation continues to work towards a commercial operations launch in 2024. In a Q&A with Avionics, a spokesperson from the company said, "Last year, our pre-production prototype flew 5,300 miles, and as part of our continuing work to validate and test our aircraft, we plan to conduct more flight tests in the coming year in partnership with AFWERX and other government supporters." Speaking on the partnership with the Department of Defense, Joby's representative stated that it is a win-win opportunity for Joby Aviation to learn, and for the DoD to utilize zero operating emissions aircraft with compelling costs to support our troops. The Air Force's Agility Prime initiative is dedicated to establishing new technology transition paths into field operationally relevant air mobility in the year 2023. It aims to combine three technology sectors: electric, large distributed propulsion systems, increasing autonomy and simplified vehicle operations, and advancing manufacturing and materials. The program is poised to meet its goals for 2023 and beyond, and in the coming year, the Agility Prime team, along with its partners, will build on the progress made in 2021. Just get here first for the information. Keep up with the latest videos. Don't forget to subscribe.